Hi there, this is a continuation of the previous video that I did on how to work out the area using integration. So I have an example 3. So the question is, calculate the area between the curve y equals x cubed minus x and the x-axis. So back to the paper and pen. So here is our curve equation, y is equal to x cubed minus x. So we need to work out the area between this curve and the x-axis. Now, if you don't have limits in your question, I would say it's a good idea to sketch the curve, and by sketching the curve you have a good understanding of what to do. So for my step number 1, let me do a quick curve sketch. So my curve equation is y is equal to x cubed minus x. First of all, let me find the points where this curve crosses the x-axis. So remember, when the curve crosses the x-axis, the y value is 0. So let me make a note of that. So when the curve crosses the x-axis, y is equal to 0. So the y coordinate is 0 at the points where the curve crosses the x-axis. So if I replace y by 0, I'm going to have x cubed minus x is equal to 0. So from this point I'm going to factorize. So if I take a common factor of x from the left hand side, I'm left with x squared minus 1, and that is equal to 0. So I either have an x value of 0 or x squared minus 1 is equal to 0. So if I take the minus 1 to the right, x squared therefore is plus 1, and if I take a square root on both sides, x will be plus or minus the square root of 1, which is plus or minus 1. So in this case I have 3 points where the curve crosses the x-axis. So the 3 points are when x is 0, y is 0. Second point, when x is plus 1, y is 0. And also, when x is minus 1, the y value is 0. So these are the 3 points where our curve crosses the x-axis. Let's also work out where this curve crosses the y-axis. So remember, when the curve crosses the y-axis, x is equal to 0. So when the curve crosses the y-axis, x is equal to 0. So let me replace x by 0 into this curve equation that we have. So we'll have y is equal to x, which is going to be replaced by 0. So I'll have 0 cubed minus x, which is 0. So 0 cubed minus 0 will give us a y value of 0. So therefore our curve crosses the y-axis at x being 0 and the corresponding y 0 as well. Now we're dealing with a cubic curve. So with a cubic curve, in this case, if you have a cubic curve with equation y is equal to ax cubed plus bx squared plus cx plus d, and further to this, if the coefficient of x cubed, so in this case, if the value of a is greater than 0, you're going to have a cubic curve of this shape when it comes to sketching the curve. However, if the value of the coefficient of x cubed is less than 0, so if the coefficient of x cubed a is less than 0, you're going to get a cubic curve of this shape. So if we go back to the example in question, so we have y is equal to x cubed minus x. The coefficient of x cubed is 1. 1 is greater than 0, so we should be expecting a curved shape like this. So let's make a note. So since our a value is 1, 1 being greater than 0, we're expecting a curved shape like so. So if we put this together on a diagram, so we have the crossing points on the x-axis, we have the crossing point on the y-axis, and we have an idea of the curve shape. So if we go back to the screenshot, So I have a diagram over here showing the curve y is equal to x cubed minus x. Now the question is, we need to work out the area between the curve and the x-axis. However, we have two areas which are between the curve and the x-axis. We have the area 1, and this area 1 is between the curve and the x-axis. And we also have an area 2, which is also between the curve and the x-axis. Now, I want you to note that 1 is above the x-axis. So remember this note. Any area above the x-axis will be positive when you calculate it using integration. However, for 2, when calculating the area of 2 using integration, as it's below the x-axis, when we calculate it using integration, we should be expecting a negative answer. However, area is a scalar quantity, so it has magnitude only. So if we have a negative answer for the area, that negative only means that the area is below the x-axis. So we discount the minus sign when working out the total area. So back to the paper and pen. So let me calculate the area 1. So 1 is above the x-axis. So area number 1. So to work out the area, we need to integrate. And we're integrating the equation of the curve, y equals x cubed minus x. So we're integrating x cubed minus x with respect to x. Now, if we go back to the screenshot, the limits of integration for area 1 will be minus 1, that will be the lower limit, and 0, that will be the upper limit. So if we go back to the paper and pen, minus 1, as discussed, will be the lower limit, and 0 will be the upper limit. So let's work out this area. So let me start off by introducing a square bracket. When I integrate x cubed, it's x to the 4 divided by 4. When I integrate x, it's x squared divided by 2. Let me close that square bracket and put these limits of integration on the right hand side of this bracket. Now what we need to do is substitute in the limits. So upper limit needs to be replaced first. So let me replace the x's here by the upper limit, giving me 0 to the 4 divided by 4 minus x, which is 0 to the power 2 divided by 2. And now let me replace the x's here by the lower limit being minus 1. So upon replacement, I'm going to have x, which is minus 1 to the power 4 divided by 4 minus x, which is minus 1 squared divided by 2. So let's calculate this. So in this case, we'll have 0 from the first bracket. So 0 from the first bracket minus, and let's calculate the second bracket. So we're going to have minus 1 to the power 4, which is 1 over 4, minus 1 squared is 1 over 2. So if I continue through, so I'll have a minus outside. A quarter minus half is minus a quarter, but the minus and this minus will make it plus. So it's a plus a quarter unit squared. It's plus a quarter unit squared for area number 1. So if we go back to the screenshot, we are expecting a positive answer for the area for number 1 because this area is above the x-axis. So remember, to calculate the area of 2, we're going to integrate also, but the limits for 2 are 0 and 1. So 0 and 1 will be the limits when calculating the area of 2. And keep this in your mind, since this area is below the x-axis, we should be expecting a negative answer when calculating it using integration. So back to the paper and pen. So area 2. So let's integrate the curve equation again, x cubed minus x. And the limits for 2, remember, are 0 and 1. So we already integrated earlier, so let me copy down the integral function x to the power 4 over 4 minus x squared over 2. So the only thing that differs are the limits, because the limits for 2 are 1 and 0. So if I replace the upper limit in first, we're going to have x, which is 1 to the power 4 divided by 4 minus x being 1 to the power 2 divided by 2 minus, and if I replace the lower limit 0, I'll get x, which is 0 to the 4 divided by 4 minus x, which is 0 to the power 2 divided by 2. Now when you calculate this, you should get a minus a quarter units squared. So we were expecting a minus. This minus means it's below the x-axis, but area can't be negative, so I'm going to write down a quarter units squared, ignoring the minus, but in a bracket I'm just going to mention it's below the x-axis. Now we need the area between the curve and the x-axis, so we need to add the area of 1 to the area of 2. So if we go back to the paper and pen, so for the area of 1 we have a quarter unit squared. For area number 2 we also have a quarter unit squared. So let's add these areas together. So area between curve and x-axis, so that will be the area of 1 plus the area of 2. So let's remind ourselves, area 1 we had a quarter unit squared, area 2 also a quarter unit squared. So let's include these. So area 1 a quarter, area 2 a quarter also. A quarter plus a quarter is a half unit squared. So this should be the area between the curve and the x-axis, and this is the solution to example 3. So that completes this example, and that sadly ends this video. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.